Hello, my name is Messick. I'm at Oklahoma State University and I'm part of the RAIN program. And the title of my project was the effects of early nitrogen deprivation on the root systems of wheat plants. And this project involved me, Carson Wright, Tegan Crosswheat, Charles Souza, and Brian Arnold. And with that, let me get started. Now, it's well known that nitrogen is a pretty essential nutrient for plant growth. It's in a lot of the fertilizers that farmers use, and it really helps increase the yield of crops. But we decided to ask the question, what happens when plants are intentionally derived nitrogen during their early growth stages? There's some past research that indicated that the early nitrogen deprivation helped to cause the roots of plants to grow larger, and it causes them to grow longer and seek out the nitrogen within the soil. And by doing this, it also helps them become more efficient. They become more cost effective, it helps plants reduce their nitrogen loss, promotes nutrient absorption, and it can help the plants retain water more efficiently. And so, the objective of our study was that we wanted to investigate whether early nitrogen deprivation actually causes root systems of wheat plants to become larger and longer, and thus more efficient. To find that out, we decided to look at the final root-to-shoot mass ratio of the wheat plant. Now, moving on to the material section, we had about 80 50 milliliter tubes, rock wool, DI water, and we used 4 genetic varieties of wheat for the test. We had GH for green hammer, IBA for Iva, DS for Don't Stop, and Gal for Gallagher. And we chose these genetic varieties because they are pretty common for farmers to use. We had 2 large pans that were going to be used to hold DI and the nutrient solutions. And in the nutrient solutions it had nutrients such as calcium, potassium, magnesium, sodium, and a bunch of other micronutrients that plants need. We had a trial for either positive or negative nitrogen, and we also had laminated graph paper so we could measure the root and shoot length of the wheat plants. And now, in the method section, we wanted to do a positive and negative control group for the nitrogen. In each group, there's going to be about 40 tubes, and we filled these tubes with rock wool. In figure 3 down here, you can see a close-up picture of the growth in the rock wool medium, and the rock wool was there just to hold the seeds in place. And additionally, there's a hole at the bottom of the tube that allowed the rock wool to absorb whatever solution is placed, and whether that be DI water or the nutrient solution. In each group, each variety was given about 10 tubes, and we placed 3 seeds within them, and we then placed the tubes over a tray full of deionized water until they germinate. A few days after germination, we changed out the DI water within the trays with a nutrient solution that either contained our positive control or did not contain our negative control of nitrogen. And then, after about 3 weeks of growth, we terminated the growth, we measured the root and shoot length, and then we maintained the dry mass by weighing the wheat samples on a scale after putting them in an oven for 24 hours. In figure 1, you can see the seed packets for the 4 genetic varieties of the wheat. In figure 2, I included it just to give an overview of the 2 trays. The one on the left is positive control, and the one on the right is the negative control. And with this picture, you can see the rock holding the seeds in place in the early germination. And in figure 4, you can see the final growth of the 2 groups. On the left side, you have the positive one with nitrogen, and on the right, you have the group without nitrogen. There's obviously a difference in the growth, but we weren't too interested in just the difference. I mean, more likely than not, the one that has nitrogen is going to cause the plant to grow bigger. And that's something that's pretty well documented. We're more interested into the final ratio between the root and the shoot, and so that's what we really wanted to test. So, moving on to the results and discussion section, you can see on the left of the graph paper that we used to measure the shoot and root length of the wheat plants. Each square in the graph paper is approximately 1 centimeter tall, so we were able to just count those to measure how long the shoot or the root was. And this really was just a secondary measurement, and we decided as a primary measurement to take the masses of the roots and the shoots and then find a ratio with that. We took the average root mass for both the positive and negative, and we divided it out to get the root to shoot ratio. And the results are highlighted in yellow. But sadly, for the most part, the data we got was rather inconclusive, and we could not confidently say whether early nitrogen deprivation had a positive impact on the root-to-shoot ratio. But despite this, the study served as a starting point for the future investigation of this topic, and it really helped to just see what methods worked and what methods could be improved upon. And this way, other future studies can be more efficient, and we're going to continue to analyze the methods and actions we have done. And we're going to tailor them to ensure that other future studies proceed in both a worthwhile and smooth manner. And just to give an example of something we will change in the future is that we're going to test more varieties of wheat. I thought it was only right to conclude the presentation with my thoughts over the RAIN program. And overall, I had a really, really good time, and I'm definitely glad I decided to do it over the summer, or for my summer. I was definitely nervous going into it. I didn't know what to expect, but the people in charge of the program, the people who helped me out, they answered any of the questions I have. They made my fears be put to ease, and even the grad students at Oklahoma State University and my mentor and the other interns that were around me, they were really nice, and I'm glad I was able to be part of this experience. It was really nice being able to partake in research again. I did it a couple years ago, some research, but it's back to get back into the research world, and I'm definitely have a deeper appreciation for it. This is my first forage into the agricultural world. I don't come from a traditional like ag background at all, but my eyes were definitely open, and I have a deeper appreciation for everything. And I just want to say thank you to the program for giving me this opportunity to do so. And I want to say a big thank you to Brian Arnold for being my mentor. But yeah, thank you.